And what this is going to be is this is all about inverses. We have worked with inverses a little bit. We did that last chapter when we were doing our story problems. We had inverses a little bit. I decided he's Yeti on the floor. So we worked with these a little bit. There's a couple of ways to write out inverses. And we've definitely seen one of them because we did these last chapter in 6, just a little bit with our story problems, where we write them with our -1, meaning inverse to undo, or it can be written as arc sign. You've probably only seen this one if you've done physics. But it means the exact same thing. It is the inverse function. So we can write the inverse of sine as sine with the -1 or as arc sign. We can write our inverse of cosine as the cosine of the -1 or as arc cosine. We can write our inverse of tangent as tangent -1 or arc tangent. So it's all those same pieces. And what we're going to be using this for is to help us figure out angles when we know other information. So we're going to start the exact same way that we used them last chapter. Sorry, I'm not sure you finished the book yet. Because it was a wheel. So we're going to start by doing them the exact same way we did them last chapter so that we can talk about a couple other things. So last chapter we looked at them kind of like this. If I give a couple of pieces of the triangle, can we figure out that angle? If I know this angle, or if I don't know this angle, but I'm looking at this angle, this side and this side, what relationship can we tell between these three pieces? Sine. We know that sine of theta is going to be what? 3/15. So if we wanted to be able to find out what sine was, what could we do? If I wanted to get to an actual value of theta. Inverse. If I do the inverse on both sides, undoing the sine, so we get our theta all by itself, we can do our inverse sine of our 3/15 to figure out what that angle is. We can do it either in degrees or in radians. I want us to do it in both. And we are going to round to the nearest thousandth. So if we're looking to do this in degrees, we're going to go on the calculator. We would need to be in degree mode to be able to do this and get degrees. So in order to change our mode, we go to the mode button and we put it in degree. So then we can do our inverse sine of 3/15. And we type it in the calculator. And since we're in degree mode, our answer's in degrees. We're taking 3 decimal places. So 11.537 degrees. It's important when you're in degrees, you've got to put the little symbol that means degrees. If it does not have a degree, it's a radian. Speaking of radian, what is our radian answer going to be for this? We have to go put it into radian mode, so it's in that same spot. Mode. I click on radians. It should say rad. It's so rad. If it's rad up there, we're in radians. So make sure you're in radian mode before you try and evaluate it to get your radian answer. Then it's the exact same pieces. Our inverse sine of 3/15. And since I'm in radian mode, now it'll spit out my radian answer. And we get 0.201. And this one is in radians. So we can find it in radians or degrees based on what mode it's in. You don't have to do a unit conversion. I mean, you can. Totally fine. We could take that 180 and pi, right? Same thing. Questions on this first one? Same vibe on the second one. I give us a different angle here. So now we're looking at this angle up here. What relationship can we tell based off of the sides we know here? Tangent. So we know that tangent of theta is what? What's tangent? 6/8. So to find our value of theta, we're going to do the inverse tangent, or the arctangent. I'm going to put it in that way this time. It's the same thing, and some calculators will write it as arctangent, some calculators will write it as the tangent minus 1. If you have a different one than the yellow calculators and you cannot find them, let me know. I can help you find it. But what do we get as our degree for theta, and what do we get as our radian for theta? Mm-hmm. 36. Mm-hmm. Yep, so we get 36.870 degrees, and we get our 0.644 radians. Okay, so what we're going to be looking at is we're going to be looking to do this with not necessarily triangles anymore. So we're going to be leaving the triangle aspect of this. But that means we have a couple of pieces we need to think about when it comes to inverses. So I'm going to start us off thinking about this specifically about sine. Yes, dear?
But do we need to write the equation? Do we need to
Oh, it was just knowing that the -1 or arc is your inverse. There weren't like formulas for it. So what we're going to do is we're going to start about thinking about sine. So I want us to think through sine and what it would look like on a graph, right? And then we're also going to, at the same time, I'm going to think back to algebra 2. And we're going to think about creating an inverse. How do we create the inverse of an equation? Switch the x and the y, right? So if we take the x and the y and we have them change places. So when we take our domain or our range, they change places, right? We've done inverses. So if we think about sine, this is what sine looks like. What would the inverse of sine look like if I was to graph the inverse? More specific. Flip it what? How? Yeah, it's going to go kind of like this, right? That's what the inverse will look like. Is that a function? No. Like really, really no. So what we're going to have to do for our inverses to be functions, since we live in the land of functions, is we're going to have to do a domain restriction. We're going to have to take a piece of sine and cut it off to look at our inverses. So let's think about sine, original sine, green sine. What is the domain for regular sine? All real numbers. We go from negative infinity to positive infinity, right? What is the range for sine? From -1 to 1. So what is the range, or I'm sorry, so what is the domain of our inverse? From -1 to 1. We're going to be looking from -1 to 1. So because we're looking from -1 to 1, now what we're looking at is which angles give us these answers. The pieces that give us our angles, our angles are going to be our answers here. So our range is coming from this. So if we're looking at sine, the pieces that go from -1 to 1, my -1 is here, +1 is here. So to make our inverse be a function, we're going to look at just this portion of sine, which means it's going to be just this portion of our inverse. So our range is looking at the angles that were here. So which angle gives us a domain of -1? Or which angle gives us a sine of -1? What is an angle on the unit circle that gives us a sine of -1? So 3 pi over 2, that gives us our -1. Where do we get a sine of 1? Pi over 2. If I said my interval went from 3 pi over 2 to pi over 2, does that make sense as an interval? No, because 3 pi over 2 is bigger, right? So that's gross. So what we do is we actually use a coterminal. Our range is going to be from minus pi over 2. Did you find them? Oh, no. To pi over 2. So because we're looking for those values, we're looking for the angles that give us the values, our range is going to be from minus pi over 2 to pi over 2. Because I can't put 3 pi over 2, or my interval is backwards. Okay, so we have to do this little domain restriction to keep my inverse to be a function.
Why would it be like, why would it not work with 3 pi over 2?
Because if I write this as an interval like this number's bigger.
Yeah.
That number's bigger. So we look at it and we go, oh, it's wrong. It's wrong, it's wrong, it's wrong. And then if we did pi over 2 to 3 pi over 2, we're over here. And like we wind up with things are weird. So we just take kind of the center, but we have to kind of scooch it to the left. So we're minus pi over 2 to pi over 2. So the reason I look at this on just sine here is because when we go to the next page, it's going to give us just these little pink pieces on the graph. So just these little pieces that got cut off. So we're looking at the restricted domain. I just wanted to explain where those pieces came from before I showed you the page. It had all of them on there, and we go, what in the magic was that? Because what we're going to do is we're going to talk about what our domain and range are going to be for our inverses. So these little pictures are the restrictions that we were looking at. So for sine, this is the one we just talked through. So our sine graph here is the red one. Our domain, we just went through some. Domain of sine is from -infinity to +infinity. But our range went from -1 to 1. So our inverse has the domain of -1 to 1. But our range can't be -infinity to +infinity or it's not a function. Our range is going to have our minus pi over 2 to pi over 2. So now we're going to think through that same kind of process, but with cosine. Cosine has what domain? All real numbers. So it's our -infinity to +infinity. What is our range on cosine? -1 to 1. So for the inverse of cosine, what's our domain? What numbers can be here? Think about what was matching. What was the y becomes the x. Our domain is going to be from -1 to 1. To think through our range, we can think about what value of cosine, what angle gives us a cosine of -1. Pi. What angle of cosine gives us 1? 0. So we're going to go from 0 to pi. Will give us the values of -1 to 1. So if we look at that on the picture here, we have our cosine, which starts at 1 and goes down to our -1. So we're looking at our inverse values here, which is actually cut off bizarrely. Oh, here we go. There's our pi. So then tangent's a little bit weird because tangent's domain is weird. What is the domain of tangent, do you remember? Definitely a part of it because that's where our asymptotes are, right? Remember, tangent is the one that kind of looks like S curves like this. And we have asymptotes in between. So it's all real numbers except our x cannot be that pi over 2 plus pi n. What's the range for tangent? All real numbers. So from negative infinity to positive infinity. So what is the domain for the inverse of tangent? All real numbers. It's going to go from negative infinity to positive infinity. Because what we're going to do is we're going to take one of those little S curves and we're going to keep it by itself, kind of like that. So I can have any x in the existence of the universe. Where is it going to land? What is our range going to be on this one? Because our asymptotes would be like this if we had them. We're going to go from our negative pi over 2 to a positive pi over 2. So when we're looking at these inverses, we're no longer looking at every number in the existence of the universe. We're really limiting ourselves to part of our circle. And I have a visual that we're going to use to help think about this on the circle. Because most of what we're going to look at is on the circle today. So I know this page is chaotic. It's a lot. What this is saying, what everything here is saying is if we look at our unit circle, oh snap, here's the circle. When we are looking at sine, all of our answers are going to be between 0 and pi over 2 and 0 and negative pi over 2. So sine lives over here. This is our minus pi over 2. This is our pi over 2. This guy's our 0. This guy's our pi. So sine lives on the right half of the circle. Cosine, we're going to have from 0 to pi. So cosine, we think about the top half of the circle. And tangent actually goes with sine. So tangent is inside the circle as well, the right half of the circle. So when we're looking at these inverses, we have restricted domain. So our answers are going to need to be between negative pi over 2 and pi over 2, which means sometimes we're going to have to do coterminals for sine and tangent, or between 0 and pi for cosine. Yep, I'll leave this up. Because what we're going to do from here is we're going to practice with these. We're going to look at some values. Because that's all the negative pieces. So our negative x's, negative y's, and all of them have coterminals up here. It's just because of if we have all these negative places, things get grumpy in the calculator. And we're going to have some of these that we do with calculators. A lot of them we're going to be able to do without. We're going to practice. Just kind of messy. So a lot of times we're going to be given problems. You ready for me to change it? That look like this. We're going to try and do them without a calculator. There are times when we are going to use calculators, but you don't need them. Because we are asked to figure out what the arc cosine of negative square root of 2 over 2 is. So we want to know what angle has a cosine of negative square root of 2 over 2. And if it helps, you can absolutely write that. Arc cosine of some number means that's going to equal the angle. So I can write this as cosine of whatever that angle is minus square root of 2 over 2. What angle does have a cosine of negative square root of 2 over 2? I was like 3 pi over 4 and 5 pi over 4, right? That's what I was just about to say. I was like, I'll set it there because I heard both answers come up. Remember with cosine, we're trying to stay, our domain needs to be between -1 and +1. So we're only looking at our top half. So we're only looking up here, and the only piece on the top half that has that cosine is our 3 pi over 4. We need to be between 0 and pi. 5 pi over 4 is not between 0 and pi. 5 pi over 4 is bigger than pi. Okay. So then I'm going to go down. We're going to look at our inverse sine of 0. So this is saying sine of some angle equals 0.
I thought arc meant inverse, right?
It does. Arc and to the -1 are the same thing. So this is the same thing. So inverse of sine is going to equal whatever that angle is. So sine of that angle is 0. So what angle has a sine of 0? 0. That's in my domain because we need to be between our negative pi over 2 and our pi over 2. So we're good to go. So arc tangent of square root of 3 means tangent of some angle is going to be square root of 3. So what angle has a tangent of square root of 3? Close. Pi over 3. Yeah, pi over 6 has 1 over root 3. So this one is pi over 3. How about inverse tangent of -1? What angle on a unit circle has a tangent of -1? So if we were just on our unit circle, we'd be looking at our 7 pi over 4, right? Is that between minus pi over 2 and pi over 2? It's coterminal with something between the two, but 7 pi over 4 is bigger than pi over 2. So what is the way I can write it that's going to be between these two values? Negative pi over 4. If I find my coterminal going this way, we go minus pi over 4. Because we need to be between our minus pi over 2 and our pi over 2. We've got to be between those two pieces. 7 pi over 4 is coterminal, but it's not in our domain, or not in our range of pi. Range of tangent. I'm good at words. Okay, we're going to keep practicing with these because I know they're weird and it takes a few repetitions for our brains to get wrapped around them. Questions on these 4 specifically? A little bit more. All right, so now we have our inverse cosine of -1. We're trying to figure out what angle has a cosine of -1. Because again, cosine, we think about our top half of the unit circle. So our angle that has a cosine of -1 is pi. So inverse cosine of -1, or arc cosine of -1 equals pi. How about our inverse sine of -1/2?
we're on the right side, right?
We're on the right-hand side. So if we need it to be coterminal with our 11 pi over 6, but between negative pi over 2 and pi over 2, negative pi over 6. Good, 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 good.
I'm not getting that part. Why can't we use 11 pi over 6?
Because what's our domain on sine? Inverse? Our domain on the inverse of sine is between negative 1 and 1, right? So, then our 11 pi over 6, is it between negative 1 and 1? It's bigger than 1, right? So it's not in the domain of the inverse. We have to have it be in the domain. It has to be between negative 1 and 1.
Well, I understand why we're doing that.
Yeah. 2 pi minus 11 pi over 6. Finding the coterminals. Okay, back to that. See it now?
Yeah.
Okay, cool, cool, cool. Actually, I guess in this case it would be 11 pi over 6 minus 2 pi. But same vibe, same vibe. That guy. All right, let's look at our inverse sine, arc sine of root 2 over 2. Arc sine of negative root 2 over 2. This one. Yes. Because it should be our, like we really want to say that one is our 7 pi over 4. That's our unit circle value. We're used to that. But because our domain goes from negative 1 to positive 1, I have to be between there. So this is going to be our negative pi over 4. Because we need that angle that's coterminal that's in our domain of the inverse. All right, how about inverse tangent of negative root 3 over 3? Super close.
Negative pi over 4?
I'm going to say 3 pi over 6. Yes, because our right-hand side, it should be, I am so good at drawing like absolutely even circles. Like, they're beauteous. So we should be at our negative pi over 6 because we need it to be between that negative 1 and the positive 1. Okay. So doing this with the unit circle makes it a little bit less, do the magic trick. When we get to something like not a unit circle value like these, that's when we're going to use a calculator. We're going to use a calculator. So we're going to find inverse cosine of 0.85. We're going to do both radians and degrees, so make sure you pay attention to your form. Make sure you pay attention to the mode. So our radians is going to give us an angle, and our degrees is going to give us an angle. So find our arc cosine of 0.85.
Wait, what are we going to do?
3 decimal places. 0.555. How about for our degrees? 31.788 degrees. Okay. Then let's look at arc sine of pi. Inverse sine of pi. What happens? We get an error. Why do we get an error? What's our domain of inverse sine?
Negative pi over 2. Pi over 2.
That's range.
Oh, negative pi over 1.
From negative 1 to 1. What's the value of pi? 3.14. Is 3.14 in my domain? So can I take the inverse of that? No. This is undefined. It's not in the inverse. So that's the reason we really need to know that, is because when we take the inverse of a thing, it winds up in those spaces. We need to know our domain. We need to know our range. Because what we're going to do is we're going to start taking these inverses and we're going to do stacking of them. Like we're going to take the inverse of an inverse. We're going to take a function of an inverse and that kind of stuff. And we'll start working with that stuff. We're going to do a little bit of that on Monday. And we're going to work with secant and cosecant. I mean, I can give you the page. Y'all actually got through that way faster than last period. So I'm going to put a page up for you guys to write. We'll work with it on Monday, but that'll give you a chance to get things written down. Because what we're going to do is basically we're going to start taking some of these guys and compose them. Like we're going to put them inside each other. We're going to do inverse or like arcsine of sine or sine of arcsine, stacking things. So there are some restrictions on that. These are properties of inverses. So, what's up? This is like, it's something that we will kind of intuit our way through. But basically we're saying is if we get x's that are in our domain and y's that are in our range, no matter if I do sine of an inverse or the inverse of sine, it's going to spit back out the value. So when we start doing compositions where I take maybe sine of pi over 2 and then we do the inverse of sine of pi over 2, it'll spit us back out where we started. But if I did sine of 3 pi over 2, sine of 3 pi over 2 gives us a value, and we're going to wind up taking an inverse that'll spit us back out with a different angle. We're going to work with them on Monday. But just to kind of give us these properties. Okay, so when we start working with them at the same time, things are going to get a little weird. But we'll be okay. Yeah. So what the plan is for next week, just to kind of talk through things. On Monday, we're going to work with these properties, and we're going to see what happens with secant, cosecant, and cotangent, those guys. Tuesday, we're on e-learning, and we'll have a Zoom call, which mostly we'll be using for question time. Wednesday is review, because Thursday's when we have our test. I will, on Monday, have the review packets for you guys, so you can have them and take them home to work on for, like, Tuesday and stuff. So that's kind of the plan. So we're going to work with our inverses more on Monday. Tuesday will be kind of the start of review. We're going to use the Teams call to like question time, that kind of stuff. Wednesday, we can work together on whatever we need to work through. Or you guys can have work time. Thursday's the test. Okay? So that's kind of the vibe. This is the last section. We're going to work with these guys all next week. It's honestly, I feel like the way that they word things here is a little bit weird. It's like it's a little overcomplicating. But I'm giving them to us. Okay. So we're going to be looking at some things on Monday that we'll still be using, but that's kind of the vibe. I'm going to put up the... hang on a second. I'm going to leave this up for a second so I have to do one thing. Boop. There we go. Okay. I'm going to put this up. I need you to remember to turn in quiz 6. Okay, that's the one that you guys took home. Turn it in. On Monday, I'll get like all the things passed back to you, lenses and all the stuff. What's up? Yep, I will go back to the thingy. I just wanted to make sure we got that up there. Boop, that page. I'll leave that up. And we'll work with them. We'll work with them on Monday. Just since we had the time, I figured I'd give you guys a chance to write it down. Then we don't have to try and like rush write it on Monday. Third gets to rush write it. We didn't get there. No, we did not do 7.5. What 7.5 does is it takes our sum formulas and our double formula and it gets you from one to the other. I'm like, we could do them separately. We do not need to smash together. So yes, no, we don't do 7.5. We just do 7.6. That was one of those things that if we had a thing that came up with that, we could brute force it and get our way there any other way. Don't need to spend time on that.